You published this book not so long ago, right? Chaos Engineering. I think the first time I heard about this term is during that time when Netflix popularized this idea, chaos engineering, and they've been running it in their production, killing their servers in order to increase the reliability. But maybe for all the audience here, can you maybe explain what exactly is chaos engineering?
Sure thing. And that's probably a good idea because there's a lot of misconceptions and the name itself doesn't help. So chaos engineering is basically this discipline of experimenting on a system, and the system can be anything. It doesn't have to be massive or Netflix scale. In order to increase your confidence, that system will survive difficult conditions. So a unit of chaos engineering, the way that I see it, is this chaos experiment, when you basically have a bunch of assumptions about the system. Obviously, we all design the systems and we want them to behave certain ways. But then in practice, it turns out that there's a lot of behavior that we didn't account for, or the system is doing what we told it instead of what we intended. So the experiment's real goal is to either confirm that your assumptions about the system are correct, basically your hypothesis works, or you find a problem, or you find a place where your assumptions and the reality don't necessarily add up. So this chaos engineering experiments, they typically have 4 steps. One is defining observability, because this is like a prerequisite for all of that to happen. If you can't observe the system, any kind of variable reliably, then you can't really conduct a scientific experiment. Then you go for what we typically call steady state, which is just a fancy way of saying this is the normal kind of behavior, this is the normal range. So let's say that for observability, we're looking at a variable like throughput, or number of requests per second that some kind of server can handle. The normal range, the steady state, might be this number of thousands of requests per second. And then we go and we do the fun stuff. So we try to turn our expectations of the system into a hypothesis. And we say, okay, so we designed the system to be redundant. That means that if we take away one of the servers from the pool, it should keep working within these parameters. And you go number 4 and you implement that and you verify what happened. The nice thing about it is that everybody wins, because if your hypothesis was wrong, then you discover something you can fix and you can save yourself trouble and fix it before your users notice. If your hypothesis was right, was correct, that means that your system is pretty good. So you increase your confidence. So, it's the nice part of doing chaos engineering. So this is really it. Like, it doesn't need to be more complicated. And then obviously it came out of Netflix and it made for some really good headlines because they were already doing this in production. Breaking things in production is typically one of the internet memes. So if someone comes out and says that with a straight face, it's a bit of a controversy. So that's really what I see as chaos engineering. I think it's simple enough that pretty much everybody can at least kick the tires and see what value they can get out of it.
From your explanation just now, so there's nothing mentioning about chaos, so to speak. It's more about scientific experiment. You know what you're going to test. You have an hypothesis, and like you have the steady state that you want to test about, and then you introduce some kind of tests and experiments. Not necessarily all like chaotic stuffs, like just killing things and doing some like one data center takedown or something like that. But it's not necessarily about the chaos itself. Although a lot of people actually has this misconception. Okay, let's just introduce this chaos software and then everything just go haywire and let's see how the system goes.
Yeah, so chaos is a little bit of a double-edged sword, because on one hand, it catches attention on headlines. On the other hand, it requires a little bit of explanation. So at least 2 things to touch upon here. One is that the chaos that we mentioned here, it's not about increasing the amount of chaos in your system, it's about decreasing the amount of chaos. In my definition, I was trying to make you picture a lab coat and protective glove wear and eyewear and stuff, because if we can't control as many of these variables as possible, we can't reliably confirm or deny our hypothesis. But the other reason for the chaos in the name is that there's an entire spectrum of things that you can do with chaos engineering. Chaos Monkey, the kind of thing that this entire discipline started with, really, was very chaotic in the sense of randomness of the word. So if you don't know much about your system, or you're looking for the emerging properties, randomness can really give you a lot of value kind of out of the box and requires very little setup. So you take the system, you release the Chaos Monkey on it, You let it run and you probably find some things. You can parameterize it, you can make sure that it breaks only a certain percentage or whatnot. And this already gives you value. And I see the sign of a spectrum as similar to the discipline of fuzzing in testing, where you produce a lot of valid inputs that you would probably not think of if you were writing unit tests manually. You just run it through whatever you're testing, and you might discover things that you didn't think of if you just cram all these inputs. And it's like brute force-ish approach, right? And so if you start with a system, it's a really nice way to get into the chaos engineering because it doesn't require much of a setup. You need to have a vague understanding of the system, you can release it, and you can find things. And the other thing I mentioned is the emergent properties. It's also a fancy way of saying that, but to illustrate that for those of your audience who've not heard about that, think about neurons in your brain. And a single neuron doesn't have the property of human conscious, or doesn't have a property of thinking per se. But then when you put them all together and they interact, from within these interactions, you have the emergent property of human conscious. Same thing for another popular example, the cells in your heart. None of them have the property of pumping blood and oxygenating your body, but put together, they create a system that actually has this property. These examples give you very nice properties, right? But in any complex enough system, you're going to have the interactions that you just didn't predict, and sometimes they're going to be pretty bad for you. So this kind of fuzzing, randomness, chaos engineering side of the spectrum is great, and it's useful, and it's part of the discipline. Over the last few years, we've been trying to push for the other side of the spectrum, where you go into the system, you already know the system well, and you're working on particular properties, and you want to make sure that particular failure scenarios are covered. From the SRE point of view, if you had an outage that you didn't predict for because the system worked differently than you expected, you would like to make sure it doesn't happen again. One of the best kind of regression tests that you can come up with is to simulate that failure scenario to make sure that the system actually still survives that. So the other side of the spectrum of the sophisticated, very deliberate practice when there is very little randomness is also available to you. Right now, as a practitioner of chaos engineering, you can pick wherever is best on that spectrum for you. And I think that's definitely a good thing.
So if I hear you correctly, this chaos engineering doesn't necessarily mean that you have to run this experiment in production. You can also run it in maybe a pre-prod or some kind of environment where you can actually simulate and do all these tests. Is that correct?
Oh no, if you don't run it in production, you're excluded from the chaos community.
Okay.
So, this is one of the things, because of all the blog posts, it's shiny. Doing stuff like this in production is unorthodox and it makes for a great presentation. But that's the holy grail, right? You want to be as comfortable with the system that you've done this for so long in the other stages that it's now part of your routine and you do it in production. And that's great. And if you can do that, that's obviously great. Because if you think about that, you're never fully testing things until they get into production. The data patterns will be different. Usage patterns will be different. So by definition, you can never fully test things on it until the actual proverbial rubber hits the proverbial road. But the common sense, sticking the chaos engineering sticker on your laptop doesn't necessarily give you a moral absolution to stop using common sense. So behind the scenes, the less shiny bit is that you are progressing that the same way that you progress all other software. You write this code, you run it in your test environments. You might increase it. You're probably going to do the same thing that you do when you release any other software and limit the percentage of traffic that goes through the systems that have that, and then increase it. If anything goes wrong, you roll back. So the same best principles really apply. Once you get to the holy grail and you run it in production, that's great. You can write a blog post and go on a conference and talk about it, as some of us do. But it's not just about that. And also, it's probably worth mentioning that there are use cases where it's probably never going to be okay. If your choice is either to potentially introduce this failure and you're not confident whether it's going to work and someone might die because of that, that's probably not the right moral choice to do that. Or if you have very heavy contractual obligations, Now, from the legal point of view, you might not be able to do that, but that doesn't mean that you can't get 80% of the value of harvesting the lower hanging fruit in the process. So no, that's a myth.
Thanks for clarifying that. So obviously for us people who are not experienced in it, there are many other more misconceptions, probably the one that exclude you from the chaos engineer group. So maybe you can tell us some of the other common misconceptions that people have.
Sure. So there's an entire suite of this, and I typically, on a regular basis, I ask my LinkedIn network to say what's the biggest blocker, and it still seems to be getting the buy-in, in big part because of this misconception. So the production one is a big one, and that's typically something that people really think. The other thing is randomness. So a lot of people basically disregard chaos engineering because they feel like it's a gimmick, a chaos monkey randomly smashing things. While for bigger systems like Netflix, again, that example, that works nicely because doing something as simple as taking down the VMs is already giving you value. It might not work for a smaller system. So explaining what we just talked about, that it's not just about the randomness, it's about an entire spectrum from random to very deliberate, is also important. Another thing I keep hearing is we already have chaos enough. We don't need new heck chaos. We've touched upon this already too, but I really would like to drive the point home that if you still think that chaos engineering is about adding chaos to your systems, then you still haven't gotten the memo. We add the failure so that the amount of incertitude, the amount of chaos in your system actually decreases. So the net, we do all of that to decrease the amount of chaos. So obviously under that umbrella, a lot of people say that because they don't feel that confident in their systems. All of our systems break. And if you are just hearing about this and you had a massive outage last week, you might feel, okay, fine, I need more maturity or something like that. I think that's a false premise too, because regardless of where you are on your maturity spectrum, you can get some value out of doing that. Typically, these chaos experiments, unless you go really into the deep weeds, they are simple to set up. They don't take that long to implement. And especially as the tooling around that gets better and better by the day, it's easier and easier to do pretty sophisticated things with little effort. Worst case scenario, you don't discover anything and you feel a bit better because you know that this particular scenario is not going to take your system down. And best case scenario, you can discover something. So it's really like the small little bets that can pay off that are really cheap to do. There's also the benefit of the kind of mindset that goes with that if your engineers and your team think about the fact that this is going to be tested, that this is actually going to be put in practice, and they have to design the systems with this in mind, it just goes more naturally to bake this reliability from day one rather than doing this as it breaks. So the mindset is also something that we could probably talk about a little bit more. But the kind of thinking that, we're not that mature, we still have outages and stuff like that, it's really not helping because at any stage in your maturity, even if you're still getting outages on a regular basis, you can get value out of that. So no, it's not adding more chaos. It's definitely not, we're not mature enough. I think one more is about the scale. People look at Netflix and they look at Google and they say, okay, yeah, these are massive companies and they're bleeding edge and they have all the scale. And that's great. But it's also worth noting that chaos engineering doesn't require you to have all this fancy and massive distributed systems. It can really work. It's more of a methodology that can really work on any kind of system. Whether you're working with a single process legacy server and you would like to make sure that you understand how it breaks and the kind of things that you expect to happen don't break its retries or whatever recovery logic, you can do that. Nothing's stopping you. So really, don't be shy, kick the tires, and you'll see that with a little bit of investment, you can get a lot of value out of that. And you don't need to be like, oh no, we're too small for that. So I think that's like my top myths that I just keep hearing over and over. It's probably too late now to change the name. So we're probably going to be hearing them